I'm Bob Potts. I am the Deputy Director with the Governor's Office of Economic Development, and it's been quite a ride over the last 11 years, spanning over 3 administrations right now, and a lot of changes afoot and a lot of things going on. So I'll talk about that a little bit, but some of my opening comments. So before I took the post as a Deputy Director, I was a research director, so most of my career has been as an economist, mostly a regional economist, thinking about how economies work, and that's a big part that we play into how we think about economic development in the state, right? And right now we're in the process of our soon-to-be released 5-year strategic plan for economic development. We're keeping it really kind of a bread and butter that kind of fits the Economic Development Administration's comprehensive economic development strategy plan. Everything with the feds is very long, and anyways, the whole point is to have a real structured economic plan, strategic plan, so that for a couple reasons. One of them is so that anybody in the state, if they want to apply for an EDA grant, they can do it under the umbrella of our plan. The other reason is so that we can span across administrations, right? So we're just coming into the Lombardo administration. I've had great visits with the governor. I think it's going to be a huge boost for economic development going forward, and I think there's going to be great opportunities going forward. As the research guy and as the economist guy, I always have to go back to numbers. And so Caleb this morning, he asked me, he says, from GOED's perspective, what are the job numbers in the clean energy sector right now? So I look at them over the decade. When I first started working for GOED back in 2012, there were 21,565 folks employed in the clean energy sector, the way we look at it. Right now we're at 48,083. So over that decade is 123% growth. That's just profound if you think about that. The other thing that we look at is what we call location quotients, our relative concentration of workers in the industry as compared to the national average. And right now we're 14% above the national concentration of workers in this industry. So you think about 123% growth, we're 14% above, and if we think about the exponential curve of where this industry is going, puts Nevada in a uniquely optimistic and super place to be right now. So then you add on top of that, if you look at the wages right now, it's all 6 figures. 102,577 is what they're telling me. So anyways, we're in a really good place. It's so great to work with these companies. We have worked with them at economic development at the state level and, across the years, of course, with Panasonic and Andrew here, going back to 2014 when we did the first deal with Tesla. We worked with Dragonfly. We've worked with Aqua Metals. I think both in 2016 we got started. I believe that's where it was. So anyways, we have a great relationship with these companies. I would like to have each one of them introduce themselves, who they're with, what they're doing, kind of where they're, a little bit of your bio without going into, the whole book. And then we'll go into some questions, go from there. So, Andrew?
So I'm Andrew Nissan. I'm the Director of Materials Engineering at Panasonic Energy of North America. I lead a team of engineers and scientists. We're working on developing domestic supply chains. Maybe I can put that in quote because it's kind of like NAFTA-y supply chains, but also supporting our manufacturing operations here in Nevada. And we announced a new factory in Kansas, so we're getting ready to support that as well. And really, it's just developing the engineers, developing the talent, making sure that we have the expertise here in the United States to be able to support all of our operations. And what we're currently doing is growing a new R&D type facility in Midtown Reno, and it's really exciting for us to be able to develop that space, to be able to have a better presence in Reno for Panasonic.
Great. Dr. Phares.
Thanks, Bob. My name is Denis Phares, and I'm the founder and chief executive officer of Dragonfly Energy. And we are a lithium-ion battery technology company. My background is very tech-heavy. I was actually an engineering professor for 12 years, and I made the crazy decision to leave a tenured position to become an entrepreneur, get an MBA up here in Nevada, and this was back in 2012, to start a lithium-ion battery company here in Nevada. And there are a couple of reasons for that, but the most important is there's a lot of lithium around here. And it's true that there's a lot of other products that go into, a lot of components that go into lithium-ion battery, but the opportunity for the state of Nevada is here. Nevada is also a great place to start a company. And Dragonfly Energy evolved as a cell manufacturing technology company. We have intellectual property focused on a novel way to produce the cells. That's a very difficult way to get up and running, so we ended up going to market back in 2016 with a line of battery packs that we branded Battleborn Batteries. And that brand went on to basically revolutionize the RV industry of all things. So now a lot of RVers have lithium-ion batteries on board, and for us, that is the stepping stone to basically getting storage batteries in every home. This is one component of the grid that we think we have the technology to address, which is basically allowing every home, excuse me, to have a large enough storage system to create a buffer to complement the other storage that would be on the grid, so that we can really start to implement a lot more renewable energy on the grid. So we're not doing electric vehicles, but we do want to support the charging of electric vehicles and ensure that the origin of the energy that goes to propelling the electric vehicles ultimately comes from a renewable source.
Great. Now to you, Mr. Cotton.
All right, hi everybody. I'm Steve Cotton, President and CEO of Aqua Metals. We have a innovation center that's out on USA Parkway that has developed a very novel way to recycle lithium-ion batteries using electricity, and rather than using fossil fuels to do the recycling process or using intensive chemicals, both of which have intensive waste stream factors associated with them. And what we're actively doing right now is operating a pilot system, which we believe is the nation's, if not North America's, maybe even the world's, first pilot system that's end-to-end, that's today producing copper in metal form, cobalt in metal form, nickel in metal form, lithium in lithium hydroxide form, and manganese in manganese dioxide form. And we're really excited about having that end-to-end system right here in Tahoe Reno Industrial Center. I'm originally from California, so I'm one of those imports that moved here in 2019. Chose to move the company and the family to help build Aqua Metals, and have never been happier to be in Tahoe Reno area and contribute to the economy and be a part of this lithium ecosystem that we're all talking about, because there's a lot of lithium here, there's a lot of players here. Getting to know all the players like the guys I'm sitting up here with has been fantastic. What's next for Aqua Metals is we have just announced a further commitment to the Tahoe Reno Industrial Center with a campus-based environment. And we're going to grow in a right-sized way to tonnage quantities of these minerals that I was mentioning earlier for production for US-based and not only US-based but sustainably based minerals production right here. And it's happening right here, right now. It's not a slideshow. You can come out and you can see it anytime and look at the metals before your eyes that are actually being produced. So that's what we're working on.
Great, great, great. You know, you always think about things that you wish you would have said, and you know, so I'm going to build on this a little bit, right? So when we're putting our state plan together, you know, we do all this quantitative and qualitative analysis. You know, I'm the big data guy, and I've got a great team that I work with on that, but we also had a whole bunch of stakeholder buy-in in this whole thing as we're building through this thing. As you go through the whole typical thing of putting together a plan with visions and missions and goals and strategies and objectives and all the things that's in a structured plan, you end up at the end of the day hoping that you have some very focused strategies where you want to go. So our focused strategies, and so this is a preview for all you guys, is it's good. We're going to title it Electric Nevada, Innovative Nevada, and Connected Nevada. And everything in this space touches on all three of those buckets at one place or another, okay? So the Connected Nevada, largely what we're thinking about there, we're thinking about infrastructure and roads and transportation and multimodal facilities and inland ports and that sort of thing. And our proximity to California, the 5th largest economy, and all points out to the Pacific Rim and all the imports that come in and the great opportunity we have there. But it also ties in with electric vehicles, right? So that ties in here. So the other part, and Dr. Phares talked about this, is the whole innovation side and the entrepreneurship side and startups and creating opportunities for a whole bunch of great ideas to get them sprung forward. So the other one, Electric Nevada, is where this is a sweet spot. And I've always talked about everything from extractive mining to final demand auto manufacturing. You know, we've got folks in here that are all on the extractive side of things and really great things going on, all the way to final demand auto manufacturing, so what was announced at the State of the State address. So we have huge opportunities in this whole space because we're closing the loop, and I don't think there's any place else in the world that's really doing that other than China. What does that mean for us in Nevada? So anyways, I came back with things I thought about that I wish I said it earlier, so I'm going to open this up, and because I think you've addressed a bunch of this. Was our first question. What are each of your organizations building in our state? And tell us a little bit more about that. You want to add more, Andrew?
Yeah, I mean, we're in the Tesla Gigafactory, but I like to say that we are the Tesla Gigafactory. We are 3/4 of that factory. We produce around 6 million cells per day that go over to Tesla. So we are high volume manufacturing, and it's just raw materials coming in. And then actually your point on transportation got me thinking about this, because as we work to kind of domesticate our supply chain, some things that we found is that things coming from Asia on boat and then getting trucked here or rail here from the Port of Oakland actually costs less than something from the Midwest coming here. And most of the time, a lot of products that we have in the Midwest, actually, we can just wave to it as it goes by on rail, because it's going to the Port of Oakland, because our rail infrastructure isn't big enough to offload things as heavy as we need. And so this is something that we really need to develop as a state to make us more competitive, especially if we want to bring in these domestic suppliers, but when shipping costs 40% more than coming from Asia, it's really hard to compete really on something like that. And I heard that's crazy, and it is crazy. And it blew my mind, and I couldn't believe it. And we had our logistics people look at it, and then we got a consultant logistics person to look at it, and we got one other logistics person, because this is a lie. And we're like, oh, looks like it's true. It's totally crazy.
We need to fix that.
Yes, absolutely. That's one thing we need to fix. And I see that as we keep trying to maximize what we can fit in containers and things like that. So everything's just going to keep getting bigger and bigger, and we need to make sure our rail spurs can handle that.
All right, great. More on the list. Dr. Phares.
There's no question. This is just what I forgot to say.
I guess the question is, what did you forget to say?
What are each of your organizations building in our state?
Right, okay. First of all, I do want to call attention to the Dragonfly Energy marketing team, who have been doing all the audio and video here. So I would at least like to give them some props. I do want to say that the state of Nevada is unique not only in its lithium, but also in its renewable energy sources, in its solar and wind. And I think we have a local utility here in NV Energy that is very well aware of that and is very proactive in trying to get more solar and wind on the grid, and very aware of the necessity for storage batteries in that regard. So I think the state of Nevada is uniquely suited to basically serve as a bellwether state when it comes to energy, when it comes to electrification. I think we are going to need a lot of help from the federal government. I think the governor also recognizes that. I think our senators recognize that. And I think there's going to be a large push to ensure that the infrastructure that is lacking, especially, we've talked about it all day today, the lack of cathode manufacturers, that is going to happen here in the state, whether it's LFP or NCA or NMC or whatever it is. So I am excited for the prospects of the state. I will agree that we're never gonna have 100% electrification. Fortunately, we don't have to have 100% electrification to make an impact on climate change. There certainly is quite a bit of uncertainty as to what the future looks like, but I think everyone will agree that the more we can do now, the easier it will be on our children and grandchildren, and that's a big focal point for us.
Great. So Steve, again, what are each of your organizations building in our state? What is your organization building?
Yeah, so we've already committed to the campus environment for expanding lithium refining and all these other mineral production right here in the state of Nevada. And that's going to bring to really the state and right around here jobs. And the gradient of jobs is very interesting, from chemical engineers and process engineers and mechanical engineers down to technicians and workers that are working with us to plate the metals and bring in materials and bring materials out that we don't have to put on a train to get to local potential users because of the ecosystem that's here. And there's a carbon impact of moving these materials around. So that's another benefit of being here and bringing that added value of all of us working together near each other to be able to improve the impact and the carbon impact of what it is that we're doing. I did hear a couple comments on what we'd like to see. One thing I would like to see, and I could wholeheartedly agree with both of these guys what they'd like to see, but I'd also like to see more green line opportunity. So right now, As we build our campus environment, anybody can go on our website and see the pictures of all the solar panels on the roof, and Panasonic's done the same, and I know Dennis will do the same with the cogeneration, but it's not enough to power our process, which is electric, and solely an electric process. So we source our renewable energy deficit from what we have to make up for with Nevada energy and with our solar cogeneration with other means, which is renewable energy credits and carbon offsets. We don't need to buy but a minuscule carbon offset because our process doesn't really generate any carbon, but being able to have the physical infrastructure that you can prove, because renewable energy credit is you're buying credits from an electron that didn't make it to your facility, and you're net zero from that perspective. But true net zero for all of us is to have green power source delivering to electrically intensive processes. So we talk about electrification of transportation. We need to talk about electrification of industrial processes, because if those electrical electrons that are coming through are clean energy based, that is going to solve the problem of why we're all doing this and why we're all sitting here, which is not moving the problem from fossil fuels to a new set of problems, but truly solving the problem. And I would love to have a whole nother panel, another set of discussions. How do we get green physical lines in here that we can all share some way, some form?
Okay, great. Great. So anyway, so let's move to the next question to you, Andrew. How do you fit within the lithium loop, and what is your impact?
So, I mean, we are the largest lithium-ion battery producer, at least in the North America. China may have got us on a couple things, but I mean, we're there. So we're the largest user of lithium, and like one thing really to me is like we have a lot of lithium producers in Nevada that are starting up, and it's really great. But ultimately, like, it comes back to what you said about cathode material. Like, we have to have a cathode manufacturer in Nevada. Right now, we can produce all the lithium we want. I have to send that lithium to China or Japan or Korea, and then it comes back to me. So we need to close that loop and be able to produce cathode here. What was the second half of the question?
No, that was it. And what's your impact? I mean, it's huge, right? I mean, with what you're doing in Kansas and now what you've been doing.
Yeah, and I see Panasonic just continuing to take the lead and be able to drive the lithium-ion battery revolution. I mean, Tesla has made big announcements. They announced 100 gigawatt hours in Nevada. Tesla has a lot of lofty goals. We have 38 gigawatt hours of installed capacity. We produce day in, day out, reliable, safe, good cells to get electrification in the direction that we want it to be. And we're the leader in the United States. And like with Kansas, we see that not changing.
Great. Dr. Phares, same question to you. How do you fit within the lithium loop, and what's your impact?
Well, we started off as a hopeful cell manufacturer, and the expense of producing cells from scratch was such that we ended up very early on moving downstream and assembling packs from cells that we bought. So we ended up assembling packs and selling those packs to the end consumer. So we did a lot of education in terms of showing our customers how to apply a lithium system with a solar system. We were very successful at basically driving lithium into a number of markets, including RVs and boats, and incorporating some other downstream markets as well. Now we're moving upstream. We're starting to make our own cells. We're building out our pilot line now with our innovative cell manufacturing processes. So we're really going from cell to end user. And if someone doesn't make a cathode for us, we'll do that too. So.
Oh, there you go. Well, Steve, I'm going to turn it over to you because I know you're going to talk about cathode probably a little bit. Yeah, there you go.
So we fit into the ecosystem today with what's called black mass as the input material. And black mass is safely collected, stored, and crushed and separated lithium-ion batteries. And it looks like black sand, but it has all of these minerals in it. And so that is the input to our process today. We do our process, again, with a path to net zero. And then the output are those metals that I was talking about, plus the lithium hydroxide. We know that it's quite possible to take cobalt metal and nickel metal and make cathode active material because that's how it's done today. We mine it and we make it that way. We view much less technology risk of going direct to powders by worrying about, is there aluminum in there, is there iron in there, are there other impurities in there? Let's get the pure metals and then be able to go to these cathode active materials. So that is an area that we will ultimately fit into the ecosystem through partnerships and through our own technologies, developed in our innovation center, that will take those metals and other things into a pre-cathode active in salts, and then cathode active material that will get back into the ecosystem. And it's kind of like, as Dennis was saying, does he have to buy the flour and the sugar and the eggs, or can he get the brownie mix and do what he does best, which is relate in the ecosystem to the end user and produce those types of systems? And so we're looking at, with our offtake partners, do we provide the individual ingredients, and or do we provide the full turnkey mix on the recipes for them?
That's great. Yeah, right. Got to get them all up there, right? So, all right, Andrew, I'm going to move back to you. What part of the lithium supply chain in Nevada need the most development in your mind?
I think it just comes back to cathode processing, but just lithium in general. We talked to a lot of suppliers that they're all about lithium carbonate. I don't use lithium carbonate. I use lithium hydroxide, which I think we natively make. Yes, we sort of discussed that a little bit, but it's really like understanding what the large cell manufacturers need and really responding to that. And it's like lithium carbonate. When I look at, say, like CO2 emissions for lithium carbonate, they always look pretty good. Lithium hydroxide, they go a lot higher because it's a transformation product. And so we need to understand that. We need to see that. And what I really like about developing kind of this whole just battery ecosystem in kind of North America is we have so much say over it. We can see these greenhouse gas emissions. We can help drive this change. Where in like China, different parts of Asia, there's a lot less input that we can do.
Right. You're kind of stuck with what you got.
Yeah, pretty much.
No, I get it. Dennis.
Well, we've discussed the cathode infrastructure. There's also the lithium salts that go into the electrolyte that, since lithium is here, it would behoove the state to manufacture lithium electrolytes as well. And just in general, I think that since there is so much volume and tonnage, the roads, the rail, the infrastructure of the state to move material around is going to be important.
Good. That's good to know. This is great for me because, we got to sell this as we're going forward here. So I'm going to turn it over to you.
Yeah, so the interconnect between all these different players that fit different ways into the ecosystem is really important. And it's things like transportation interconnect. But I would even say what we're doing here now. We've just formed this Nevada Battery Coalition as an organization that was announced today. That's the interconnect that we also need to do. And that fits in with public-private partnership opportunity. There's lots of grant money, there's lots of loan money, lots of support from the state, lots of support from the feds. But we all need to be talking and working together. And I love that we're doing this, and that this is like going to be looked back at as the kind of birthplace of when these lithium players in the state really got together and said, how do we all work together? I have a term that I'm sure you guys have heard of called co-opetition. And in many cases, you're going to cooperate, but you're going to be competitors. But everybody has their area of specialty and fits into the ecosystem differently. And I think that the more open and transparent we are locally in this community, let alone the state, the better off we're all going to be as businesses, and the better off our economy is going to be.
Well, to that point, this is kind of a dream for me. I think Caleb and I, what was it, Caleb? We, 6-8 months ago, we got together and Caleb said to me, he says, where do you see what needs to be done? And I says, need to get everybody in this space together, and I don't want to create another mining association or something like that. I want to have, because guaranteed everybody's going to have some of the same problems. They're all, they talk about SWOT analysis, strengths, weaknesses, everybody kind of shares those, but there's an economies of scale that can help us through some of those as well. So anyway, I know you guys have talked about cathode being a big part of this, right? So Andrew, explain a little bit, what is cathode manufacturing, and from your perspective here, we're going to kind of go through this.
So cathode manufacturing is the most complex thing in the entire battery supply chain. It represents over 50% of like the bill of material costs for our cell. And it's because it is so complicated. You got to start with mining the metals, and then you have to go to precursor, then you got to bake, and then you have to make the cathode. And then there's some additional steps that I'm not even 100% sure about. The cathode manufacturers, like, this is the highest IP that I've ever encountered with any suppliers. So they're very like hush hush, but everyone has their secret. little formulations that go into this to get what it needs. But I mean, this is really like the heart of the battery. If the cathode isn't made correctly, then we call it taking a knee for the battery. So you'll see like a slight capacity loss, and when it takes a knee, it just drops. Right. And as the end users of batteries, if you have an EV, you don't want that to happen. You'll just be driving down 580, and then suddenly your car is like, nope, we're done. And so, Panasonic, we spent a lot of time engineering this cathode, and it's been years and years, and like kind of the bread and butter for Panasonic is nickel, cobalt, aluminum. Like this is what we're known for. This is what we do. We are the best in the world at it, and it used to be that we would have NCA because it gave us the highest energy capacity. Now the NMC cathodes are getting closer to it, but still NCA for your EV performance is the best. So when you hit that go pedal and you want to like destroy the Mustang right next to you, you want an NCA cell in your
Unless
car.
it's one of those Mach-E's that maybe have a shot.
No. Teslas will still pass those things because they got the NCA cells. So you want a Panasonic NCA.
This is this cooperation or whatever you call it there, cooperative competition, right?
I mean, it's nice, they look nice in a rear view mirror.
which I do all the time with my Tesla.
There you go.
Dennis, you weigh in on this one too, as far as the cathode manufacturing. If you will.
Well, there's different kinds of cathodes, and they can all be made to different levels for different applications. Sometimes you want high power, sometimes you want high energy density, sometimes you want just a lot of energy packed into one cell, and you don't need necessarily the power, and they're all done differently. We've talked about the different chemistries, lithium iron phosphate or lithium metal oxides or lithium ternary metal oxides or whatever, and there are different mechanisms to make the same type. So lithium iron phosphate can be made from solution, it can be made from solid processing, it could be made from a flame or a gas, and so it just depends, and for Dragonfly Energy, we've got an idea of what we like and how we want it done, and the same goes for the anode, and the anode is typically graphite. Now there's more and more silicon infused in the graphite. Some folks are trying to figure out how to do lithium metal, but I think just in terms of the anode, when you first charge up the cell, there's a reaction that happens called formation that forms a little crust on the anode, on the graphite, and the ability of that crust to survive cycling determines the whole. So that the cell performance is determined by, a nanometer scale crust that forms on the very first charge. So
that's crazy.
There's definitely
really
a lot
crazy.
of IP and secret sauce that goes into it. Everyone does their own thing.
Sure.
So.
Very interesting.
Make sure they delete that part of the video.
It's his team, right? All right, Mr. Cotton.
So I'm excited about the battery energy storage application in addition to transportation. It's always the EV that we talk about because that is a lion's share and a big portion of the industry, but more and more we're seeing battery energy storage happen. And battery energy storage, you're solving for different things. You're solving for, I don't want this thing to catch on fire if I'm in my RV or if I'm in my house. And you've got that kind of application with an LFP, a lithium iron phosphate battery is a little less volatile, a little less energy storage capacity, but being able to take that recipe and that technology and apply it towards battery energy storage, I know is really key. I was just earlier this week down in Half Moon Bay with this secretive gathering of all these hyperscalers. So Google, infrastructure leader, the Facebook, Meta infrastructure leader, Microsoft, et cetera. And I took a poll with them and said, what battery chemistry are you guys using? In battery energy storage system, it's all LFP. They also talk about sodium ion, which is an interesting technology that might be another upcoming thing that the state of Nevada and this group of companies should think about as well. But that's what's interesting to me is that as the battery energy storage and transportation and overall electrification happens, these chemistries and the way that we deal with these chemistries and the way that we make those cathode active materials is really important.
How'd you get into that party?
Invite only.
Mine got lost in the mail, I guess.
I mean, at the end of the day, it sounds to me like there's a place and a space for everybody, that there's a whole spectrum that goes through there, all the way from production all the way to application. Right?
Yeah.
So that's really great.
Yeah,
So,
one other comment on that too, just so everybody can internalize this, big data centers, have 100, 150 megawatts coming into these things. And right now, the way they back up the power is through diesel generators. For long, sustained outages, they have some battery for ride-through, so they can get the generators fired up and synchronize the harmonics and get the servers fooled like there was no power outage. The EPA is more and more saying you can't run those generators, even to test them. And so they've realized, well, let's replace all that diesel generator infrastructure with massive megawatt hours and even gigawatt hours of battery energy storage systems. And so that's the direction that data centers are going. For those of you that didn't realize that, that is kind of a huge transition that's happening with the internet infrastructure.
so that's interesting. So diesel production, the EPA is coming up against that just because of
Emissions from those diesels. So if you've got literally 20 or 50 or 100 megawatts of diesel generators running, it's a little stinky. Yeah. And it creates a little problem, especially if it's running for 8 days and things like that. And so having that level of battery energy storage.
Well, but that could spin off and affect a lot of things. Hospitals, anybody that's got backup.
Yes. The applications for battery energy storage is phenomenal, and it's not the sexy car, but there is a huge market that's out there that this state and these companies can all be a part of that ecosystem.
All right, I'm going to start again and say, Andrew, how does recycling help on the cathode manufacturing side of things? How does it contribute?
I'm going to go beyond cathode, just recycling.
Yeah, sure.
So our partner in recycling is Redwood right now, and it's a way for us to just close the loop with them. And one of the things we're doing is producing copper foil from our recycled products. Eventually, cathode can come along. Cathode is just so complex; it always lags. So copper foil can come first, but recycling needs to be a big part of it. But recycling can't be the only part. We do need an area that's still virgin materials, and so we've been on a lot of different like government boards, things like that, and they say, well, recycling, you got to show that X percentage is recycled, but you can only get so much if you're thinking we're going to continue to grow. If you're holding steady, then maybe that's a different kind of mindset, but just in general, recycling is a great idea. We definitely embrace it. We're looking to expand, but we need these packs to start coming back from the Teslas and the VWs and the Mach-E's and everything else so that we can get this in volume. Like, we all have cell phones, but that's not going to get us out of this. So it's really now when EVs are coming back, this is the first time that recycling can actually be a viable thing, in my opinion. Otherwise, your feedstock is just not quite reliable enough, as I understand it.
So does it kind of help, though, to bridge a gap until extractive mining can really get its legs under it? Mm-hmm. So.
Yeah, every atom of nickel, cobalt, aluminum, iron, copper, we'll take it. But it's, it is a little bit faster. I imagine a recycling facility can get going faster than any mine ever can. And, well, I'll let you speak to it, but what's nice about the recycler is they can get to these pure components pretty fast in their recycling process. Right. Whereas mines, it'll take years to get there, and even that, again, we still have to send a lot of that over to Asia for processing.
Could pull out Mr. Crowley and you could comment on that. Years to get it up and running?
Well, we're going to have about a 30-month build out, and that comes after more than 10 years to get to where we are now.
Okay.
So it takes a long, long time.
Great. So wherever we can get it and get it going. So, Stephen, on this, excuse me, I'm going to jump ahead on you. Dennis, please.
Oh, well, we've talked about the breadth of the consumer markets here between data centers and electrification of everything involving elimination of diesel generators. There's not going to be as much competition downstream as there is upstream. So any place we can get all those components, we want to optimize that. So I'm a big fan.
All right, Steve, you weigh in on that.
Just got to deliver. So the recycling component is interesting. You know, Aqua Metals also has AquaRefining for lead acid batteries, and we found out a way to do that in a very clean method that doesn't have any carbon emissions associated with that as compared to the incumbent method, which is smelting, which also, by the way, is the incumbent method of today's lithium battery recycling, which, by the way, recovers 0% of lithium. It recovers the nickel and the cobalt. It burns the lithium and it goes into the air. Not so great. So because of that experience in the lead industry, a couple data points I can share with folks is that the recycled content, if you go and buy a new lead acid battery today, is about 90% of the metal that's in that battery, the lead that's in that battery, came out of old batteries. And it's just in the ecosystem because it's more of a mature battery market. It's a $65 billion market. If you buy a new lithium battery today, does anybody want to guess what percentage of the minerals that are in that are recycled? 0. 0.0. And so that's about to change. Panasonic's partnership with Redwood is going to have some of the copper. And then ultimately, as we begin producing the lithium and the nickel and the cobalt and also copper, that will start to go in. And I remember it wasn't too long ago that Energizer was bragging about 4% recycled material in their alkaline batteries. And that was a big splashy thing. And the lithium world is going to go up and up and up like that. However, another comment on just volume of material available for recycling. Yes, there is a tidal wave of EVs that's coming, but we have been pleasantly surprised for our business how much of this black mass is available from things like laptops and cell phones and all the materials coming back. And it only takes 147 iPhones to get enough cobalt to make a whole EV. And so, you know, when there's millions of them, there's a lot of black mass, and that's what we've chose to focus our business on is like, let's source that black mass. Let's not worry about gathering the batteries and crushing them and separating them because there's a lot of other people that are really good at that, and it is not easy and it's complex. But the material is out there and it's available for our aspirations, which is to get to that 10,000 ton per year capacity in the coming couple of years.
I love that 150 iPhones per car.
Yeah,
That's a cool stat. Huh?
I mean, I have like 15 of them in my drawer.
That's how that goes, right?
Just about ready to send off to our black mass provider partners.
So the next question, I'm going to start with you again, Andrew. What are we doing to close the lithium loop equitability for all Nevadans?
Ooh, good question.
That's a good question, isn't
But
it?
just
It's not my question.
maybe just equity in general is something that we're really working towards. So like Panasonic does apprenticeship programs with TMCC for our operators and our maintenance techs. And it's really like, as we build up this whole battery infrastructure, like it's not just lithium, it's really the battery industry in general. Like we need to make sure that the people that live in Reno aren't left behind, that they're part of this, that we can help them grow and expand. And I mean, it's mutually beneficial because we're training them, but we're also getting these experienced operators and maintenance techs for us, which we need anyway. And if they're from Reno, they're probably going to stay in Reno. So, I mean, this is really just a great opportunity for us. And another thing that we're trying to kind of build up a little bit more is an awareness of the indigenous population and how lithium mining may or may not affect them. Because it's not just plop a mine on land and just start digging and get the lithium. We need to make sure that the communities are involved, that they're engaged. And like some of the things that we're trying to do around that is like our internship program. We're trying to actually have more of an education piece with that, where we take them to the Native American colony that's actually oddly very close to Midtown, and just teach them about the population here. So there's always this education piece, and we need to make sure that everyone's coming along for the ride with us. It's not just we're going to scorch the earth, make our money, and move on. Like, this is our community, this is our home. We're going to develop it. We're going to develop our community. We're going to grow this for Nevada.
That's great. That's great. Dennis?
We're not planning to scorch the earth either. You know, obviously the more of the supply chain we develop in the state, the more the money stays in the state, and that's good for everybody. And, you know, we've got a great relationship with the university, the local university here. We recruit heavily, and we'll continue to do so. You know, we now are a place that Nevadans that grew up here and went to school here can go to work.
Mr. Cotton?
So we're definitely working on community impact and community involvement and all those tentacles with the local universities, TMCC, UNR, et cetera. and applaud Panasonic for creating that program that we can even benefit from, and that's part of how we help each other out in the ecosystem. And we've recruited and supported employees from those places. Another area of focus for us is worker safety. In our worker safety environment, the PPE or personal protection equipment you need to work with when you're doing aqua metals processes is like a pair of safety goggles. And that's pretty nice working environment. And one of the things and challenges that we've seen is if you have an industrial process that could potentially be a little less safe and a little more difficult, and you want to create jobs that people want to have. Or else they're going to put on their AirPods and go drive a forklift over at the Walmart distribution center. And so we're trying to create jobs that even at the moving materials around level are comfortable, good, happy, safe jobs. So lastly, I'll point out the indigenous population. It's really important to make sure that we work with them. And there's tension between the mining and the indigenous population. I also applaud the mining companies I saw today are really doing a lot to work with the indigenous population as well. We are too. And that's because there's great jobs for them. The younger generation, as we've learned through our engagements, is very interested in these tech jobs. And so we don't have to promise that we're going to build something on one of the reservations, but we can work with them to bring in that talent and support them and provide internships ranging from that range all the way up to the work that we do with the colleges that they also participate in. So it's a real important aspect of our strategy.
That's great. Yeah, so as an economist, a lot of times we talk about industries as export-based industries or import, or primary or secondary industries, right? And everything in this space, that's why it's so popular with economic development, is because most or a good portion of the goods or whatever that are produced in this are sold outside the economy, and then the money flows back in. So, and for economic development, that raises the tide for everything else. So as we know, things are really tight up here in northern Nevada, and I talk about this a lot, that the community kind of has to start catching up with the economy because of all the activity going on, whether you're talking about scarcity of workforce, when you're talking about crowded schools, all these things, that you have to think cohesively as you go through this. So I'm going to ask the question here, have you guys got any thoughts about operations in other parts of Nevada, southern Nevada, rural parts of the state? How do you think about that? Andrew, any comments on that?
Well, I mean, for us right now, it's here. We're in around like $5 billion into that factory. Where we can't really divest. Like the point of that factory is we got everything all in one spot. So like other areas of Nevada, I just see it being a little bit more stressful to find people, get materials transported, things like that. So for us, it's pretty difficult. Sure. We need to be centralized.
Get it, I get it. Dennis?
Well, right now we have all of our operations within the city limits of Reno. Mm-hmm. And it really depends what happens in the future and how far away we have to move from our current activities. If we have to move upstream, then it probably would entail a move outside of Reno. Not a move, but an expansion outside of Reno. But right now there are no plans. We're expanding within the city.
And I know, Steve, you talked a little bit about the program that we worked with TMCC. That was a WIN program, Workforce Innovation for a New Nevada, on the MT1, 2, 3, and creating that curriculum, right? How are you thinking about other parts of the state, even if we talk about bringing workforce from other parts of the state, if we have shortages here?
Yeah, so we're too focused on right here to get this campus environment built and up and running. But ultimately, as we build partnerships, we have opportunities to joint venture and co-locate. And some of the folks that we're talking with have potential or existing operations in other parts of the state. So I could see us being a part of those operations, but our core operations really are here. Now, this is the birthplace of what we hope is AquaRefining for the world, that we put these clean, electrically powered recycling facilities elsewhere. But that creates jobs here too. That creates like project management jobs, road warrior jobs, and all the things associated with managing a fleet of these recycling centers throughout the country and even throughout the world. We, for example, have one facility that's in Taiwan with a partner right now. which I'm a little worried about with the political environment in Taiwan. But it is important for us to make this the nerve center. We've made that strong decision that this is no matter what the nerve center. What I am a little worried about is what I saw last week at the EDAWN event, if anybody was at the EDAWN event, and there's a crunch on housing. And we may, with all these great companies that are growing and all that, find ourselves with the people shortage. And that's something that we have to work together to try to avoid. And that is, I know Mike's at EDAWN's top priority is more dense multiple dwelling unit type housing so we can get folks living here to be able to fulfill all these great jobs we're about to offer them.
Yeah, no, those are the kind of things we think about all the time. One of the things you just mentioned, and then I'm going to turn it over to the audience. I think we're getting a little close on time, and I want to leave a little bit of time for Q&A here, is a political sensitivity. So when we talk about this whole industry, it's more than just transportation and just energy storage, it's climate change, it's thinking about a whole host of things. One of the things, because so much of the processing has always been on the Pacific Rim, how do you see this affecting national security, and is national security a good story and a media push as far as helping us to build this? I mean, is it really an important part in this conversation?
Yes, is the short answer. China has invested so much over the last few decades to really be the leader in this, and something like the Inflation Reduction Act that has completely shifted the balance here. Like, for the first time, we're getting incredible traction with companies saying, actually, I would like to make things in the U.S. for your battery. And so we're meeting with more suppliers, we're growing these, but it takes time. And, we keep talking about cathode, but I would say you miss one component of a lithium-ion battery and you're not getting a battery. So it's like we need all the components all at the same time, and these take large capital investments. And U.S. companies seem to be much more hesitant to make these investments than, say, like a company in China that appears to just like make a new aluminum rolling line. And they're like, oh, we'll find customers. And then the US mills are more like, well, let's wait until you can really show this demand and then I'll make this investment. And then we're talking 18 to 24 months. So it's really the IRA has helped us to like push them to say like, hey, we're building this stuff. We're going to build more. We are going to continue to grow. And they're finally starting to see it, and they're starting to like step up. And that's what we really need, is the U.S. companies to step up if we're going to do this strategically.
Great. Dr. Phares.
Well, American investors don't have a great track record of investing in manufacturing. So companies certainly need to step up, but as a company that started here, I can tell you that there wasn't a whole lot of interest 10 years ago to put money into something that wasn't an app or a website that would have a rapid return on investment. So I'm really happy that there is a renewed focus on manufacturing domestically. I think it's critical for our economy. We certainly have very friendly partners that we've worked with in China, and I'm not going to say that Dragonfly Energy would have been able to grow without our partners in China. That's not the case. But at the same time, it was always the mission to innovate here and manufacture here. If we're innovating here, we ought to reap the benefits, right? So that's really what we're trying to do. And to second what Steve said, we do want to be able to export this. If we make Nevada the bellwether, there's no reason why you can't, get lithium from Croatia and then set up, storage plants over there as well. So, it's a global effort to mitigate climate change, and hopefully politics doesn't play as an important, a role as it's playing right now. But I think America has just been falling behind, and it's time to catch up.
Cool. I'm all about that.
Yeah.
Steve.
Yeah, it's time to catch up and time to lead, I think. And right now we are behind. And national security, so I said earlier, solving the problem versus moving the problem from the global climate change perspective. Let's make sure that the way that we build and run and recycle and close the loop with lithium is a problem solver. What we're trying to solve with national security is energy independence. And energy independence has been a big deal for the whole oil and gas era of our world's development. Wars have been started and won and lost over desires to be energy independent. If we're going to really become an energy battery country with clean energy, we need to be energy independent to certainly almost the full degree. Now, there's some folks in Europe that aren't happy about the US government and its strength passing the IRA and other things, and their side meeting saying, hey, you're hurting our countries because the US has too much money and you're doing a big grab of this energy space. So that's kind of an interesting dynamic, but that also means that the US is kind of doing something right, because it is absolutely critical that we secure these minerals. And I saw 2 panels ago a chart put up by, I think it was Lithium Americas, that showed, and actually 2 others had that chart because it's so good, and it shows the content of the minerals that are coming out of this country, and it's embarrassing. And so we have to get there. And I think every step that we make towards that is this ecosystem where a lot of it's happening right here is critical.
Great. So we got a couple minutes here. I'm going to open it up to questions. There's got to be, please.
I want to say I appreciate greatly that you discussed community. That's a conversation that I think is very hard to tackle because it's a very big thing, but it's also a very important part of everything that we're doing, especially developing a new technology. So I come from Story County, where historically we were the innovators of the world, and here you are again doing this what the mining people did 150 years ago. Congratulations. But community is so integral that we, at the ground level, have a real understanding of what you are doing. And you've talked about education, in institutions, and you've talked about reaching out to the Native American groups, which I applaud all of that. But are there plans? Do you have any idea about how you reach out also to the larger community to help us better understand what you do and how you do it and why?
So one thing we're doing, mark your calendars, is April 27th, having a showcase of our facility so people can come and see it. Whether you're a shareholder or a stakeholder of any form, a community member, a concerned community member, what's going on in there, all those kinds of things. And so we're making that an important priority for community involvement, community understanding and internalization of what it is that we're doing. So I'd say that's our step that we're taking in the near term that's real and tangible. I'll let these guys comment.
Yeah, we have something similar coming up with our NSET event, which is, when is that?
Next Wednesday.
Next Wednesday. So we've got our facility open up next Wednesday to show it off. And I think just in general, we sell direct to the consumer. So we're always talking to the end user and teaching them, about basically renewable energy. Lithium is a big part of that. And, I do think that if you have somebody in their van that's got solar on their roofs and they can basically live off of that because they've got 400 amp hours of batteries there, they teach their friends. It's really like the way batteries grew is because we just basically put it out there and people started telling their friends and sharing their own experiences online, and I think it's a great way to spread that message. But we're from Nevada. That's why we call ourselves Battleborn Batteries.
Yeah,
so.
there you go.
Yeah, I think for us, having people come out to the factory isn't really something that we can do. It's pretty difficult, but this is where our development in Midtown is really exciting, because this will give us, once it's complete, the first opportunity to engage more with the local community as well, because it's also, people don't generally want to drive 30 miles east of Reno to go do something. So that's kind of how we see the engagement with the local community as we move forward, is to get them more excited, kind of work more with the middle schools and high schools, things like that are around us too in our Midtown location. And being a non-manufacturing site would be the first time that we can really get visitors to be able to see what we do and touch and feel the batteries themselves, because it's pretty crazy when you actually unroll a jelly roll, which is the core of our battery. To unroll that for the first time is quite the experience.
And it eliminates fear. I think that's the important part.
Yeah.
True.
Sure.
Thank you all for the presentation. I'm interested in the virtual power plant idea, so that once these batteries are manufactured, there's a lot that goes into it, we can utilize them more. And so that people who have these large assets, like the batteries they might buy from you for their home, can service the grid and help accelerate the green stream that you're looking for of renewable energy in our state. And so I thought there could be a Reno metropolitan hub of a virtual battery where renewables feed into that, and then the grid can use some of that, and they can monetize that asset they have in their home, or even these huge batteries they have in vehicles. That, when you buy an EV, you oversize your battery because you're looking at your edge cases. But 97% of the time, you don't need that huge battery. And if you got a place you can plug in, and that energy can go into the grid, into a virtual battery there.
Anybody have thoughts on that?
Well, I'd like to say something about that, because the way we envision it is basically a battery in every building that is grid tied. And we envision that such a scenario could be mandated by the utility company, because ultimately it will be worth their while to put up a renewable energy plant rather than building another gas or coal plant. And they can only do that if there's enough energy buffer on the grid coming from, the batteries that are on the grid. And the nice thing about distributed storage, about having it in people's houses, it means less transmission. So energy isn't moving so far, and you have truly a smart grid. You can really manage energy packets in a much more efficient way. So having storage everywhere would make the grid more solid and more efficient.
And you can keep it more local, like Wheeler Power can work on Ely.
Interesting. Anybody else want to weigh in?
I would add that Nevada, as a state, it amazes me, is behind other states in the nation in terms of net metering and the way that we work as a user of grid power with the grid. And if we are really going to be the lithium state, if there's any legislators out in the audience, think about legislation that also hopefully the utility gets involved with, so we have better programs for exactly what you guys were just talking about. I don't see any reason that if I choose to buy a larger system than my house needs because I want to be in the business of exporting electricity, that I can do it because I can feel good about it because it's green, and I can also maybe make some money doing it. And I think that, and then when we have these rolling blackouts, maybe we won't have them because we have that energy storage and it's tariffed properly by the utility. And so that's certainly an area that we need some legislation and some help associated with that.
Great conversation. Do you want to weigh in at all, Andy?
Just using the EV as grid storage. I mean, it's a really good idea, but it's a use case that needs to be considered very carefully. Like lithium iron phosphate, for example, is an amazing cell chemistry for grid storage. In CA, maybe not quite as good. And so you just need to make sure that you're not degrading the packs, and that's something that Panasonic's going to have to work with Tesla on, because ultimately it would be Tesla that has to let the electricity go both directions. We're just cell manufacturers.
Get Tesla to put a few Tesla power walls in the big trucks that you can take out and run your truck more efficiently when you don't need them.
Yeah. There you go.
I want both. I want power walls, power packs at home, and the EV for the deep cycle.
Yeah, absolutely. And I think one thing that also just in general needs to change, I've seen the Ford ad for the Lightning where you can plug it into your house if you have a power outage. And in the ad, people are smiling, all their lights are on, their fridge is open, their TV's on. I'm like, that is not going to be the case. It's like you turn on your two lights and you're not using your AC. This is also what people need to understand. A pack, how much energy a house really uses, and it's going to go fast.
200 kilowatt hour Hummer.
Yeah.
Yeah, you can go a ways.
Right. Just we need to temper expectations of running my AC in the middle of the summer when the power goes out and being like, yeah, I got my house down to 55 degrees. It's probably not going to happen.
You don't need to. You keep your fridge going.
Yeah, exactly.
Well, I think we're over time. Is there any other burning questions else we're going to call it? I know this is the last session. I believe it's the last one of the day, right? And so we can go on a little bit if you want, but I'm ready to call it if everybody else wants to. Any other burning questions here? All right. Well, I really want to thank the panelists, Steve, Dennis, Andrew. Really great. Appreciate it. Thank you, sir. It's really great to meet you in person.